Hello friends, good morning and welcome back to Relief Tutorials. In the last lecture we have discussed about some terms connected with waves. Students, up to here we are just discussing about waves. We are still not in the topic of sound. But because sound is a wave, we have taken the introduction of all the terms associated with the wave. Let us recap them fast. The first term we have seen was amplitude. Amplitude means maximum displacement of a particle from its mean position, or we can say maximum displacement of a wave from its mean position is called as amplitude of that wave. Symbolically, it is air and unit is centimeter or meter. Then we have seen wavelength. Name itself suggests you it's a length of a wave, length of one wave. It is symbolized by lambda and unit is centimeter, meter or angstrom, and 1 angstrom means 10 raised to minus 10 meter. Then we have seen frequency. Before that, I think we have seen periodic time or time period. Periodic time means the time required to complete one wave is called as periodic time, symbolically T, and its unit is second because it is simply time. Frequency symbolized by F or nu. Frequency means number of waves completed in 1 second. Number of waves completed in 1 second is called as frequency. Periodic time means T. And then I think we have seen wave speed. Wave speed, it's because it is speed symbolized by V, speed of a wave. In these all topics, we have seen the different formulae during this discussion. Formula for frequency. Frequency is 1 by P. In place of F, we normally write nu in your NCERT textbook. Frequency is generally symbolized by nu. Frequency is 1 upon periodic time. Periodic time is 1 upon frequency. Speed of wave is lambda by periodic time. Another formula, lambda into nu. And from this relation, lambda is equals to V by nu and nu is equals to V by lambda. These formulae we have seen. Remember, these all were the characteristics of a wave. But we know sound is also one type of wave. We have seen sound is a mechanical longitudinal wave. Sound is mechanical longitudinal wave. Now, let us go towards the sound. Let us focus on the sound now. First question we have to solve is how the sound is produced. How the sound is produced. I am speaking here, I am producing sound. When I tap on the board, I am producing sound. If we are playing tabla, we are producing sound. How the sound is produced in all such cases? Remember, to produce sound or sound can be produced by vibration of a body. Something should get the vibration to produce sound. Something to get vibration to produce sound. When I tap the board, the molecules of these bodies starts vibrating, starts oscillating. and that is why it produces sound. When we play tabla, the skin of tabla starts vibrating, so it produces sound. And I think you might be knowing that when you speak, the vocal cords are here, and the membranes of vocal cords starts vibrating when I speak, so it produces sound. I think you know about the harmonium also, that when we feel air starts vibrating, and because of that vibration only sound is produced. One of the question is there in your textbook on page number 165 or 166, I don't know. One blue color question is there, how your school bell produces sound. So school bell is a steel body. When we strike the bell, the molecules of that steel starts vibrating and it produces sound. So conclusion, something to get vibration, something should be getting vibration so that the sound is produced. So now whenever you hear any sound, whenever you are producing any sound, try to find out which body is vibrating. Now tell me, can we produce any type of sound in vacuum? So you will say no, because in vacuum there is nothing to get vibrate. There is no material particles are present in the vacuum, so nothing is going to get vibration. So sound cannot be produced in vacuum. Okay. So conclusion, some sound can be produced by vibration of a body. Second question to discuss is how the sound propagates. In the very first lecture we have discussed that we are going to solve all these questions. You are sitting on the first bench and your friend may be on the third or the fourth bench. So you speak, means your vocal cords starts vibrating. So you are the producer of sound. But now how the sound reach to your friend's ear? So you are on the first bench, you produce a sound. Now this sound propagates through medium. The sound which is produced by the vocal cords of your body, vibration transferred to the molecules of air. Now this molecule passes this vibration to next molecules, next layer, and finally it reaches to your friend's ear. When someone is playing tabla or some any musical instrument, it can be heard at certain distance. So the sound producer means when we play tabla, the skin starts vibrating, so that is a sound producer. Now this vibration passes to air and it reaches to your ear. When the school bell rang, the steel body of school bell is a sound producer. The steel molecules of school bell starts vibrating when strike, so it produces sound. But now this vibration passes in air in the surrounding, and now these molecules of air passes this vibration to more number of molecules of air, and the whole school can hear the sound because of the medium there. So how the sound propagates? Sound propagates through medium or particles of medium surrounding to sound propagates through medium. Yes, that's all. Sound propagates through medium which is present around sound producer. It is present around the sound producer. So already we discussed about that. The sound always require a medium to propagate. Sound always require a medium for producing also, and sound always require sound only can be produced in a medium, and sound only can be propagated in a medium. That is why we called it as a mechanical wave. One of the activities there in your textbook, if you see on page number 164 or something, that there is a jar and there is a bell inside it, just like a ringing bell. There is a bell inside the glass jar. The wires of this bell is outside the jar, and now the bell starts. When we switch on, what happens? The bell starts ringing. It is inside the jar. The mouth of the jar is closed actually. Just through one or two holes, the wires are coming out. Now you switch on. So now the body of bell starts colliding with each other. The steel body again. So they are the sound producer. Now the bell is surrounded by the air of jar. So that vibration passes to air. Now air vibrates and the jar is here. So the vibration then passes to glass material of the jar and the vibration comes out of the jar and again it passes to air and you can hear the sound. Now attach the vacuum pump at the bottom and starts evacuating the air from it. It starts sucking air and try to produce vacuum inside the jar. So when you start absorbing the air from the jar, gradually the bell is still on, the switch is still on. So when you start sucking air, absorbing air from the jar with the help of vacuum pump, what happens? That the sound which you are hearing of the bell starts going feeble, means the sound decreases, and as the whole air comes out, the body is still colliding, but you cannot hear the sound because sound cannot be propagate without medium, because now around the bell there is a vacuum. So there is activity in your textbook just for your information, and you can easily learn it if you want. So two questions are easily solved. How the sound is produced? Sound is produced by the vibration of one of the body. And how the sound propagates? Sound is propagating. Sound propagates with the help of the medium which is present around the sound producer. Now, just like we have seen the frequency and wavelength and amplitude are the important terms associated with the wave, we have some very important terms associated with the sound. So, very important. Important terms connected to sound. The first term is pitch of sound. Pitch of sound. Shrillness. Pitch means shrillness. Just like what some girls shouting in your ear. The voice produced by the girls having the high pitch. Two types of sounds are there, shrill and hoarse. Rough sound. Rough. Just like what the boy is normally having rough sound and the girls are having high pitch sound. I think you have hear the Shehnai is playing in some marriage function. The Shehnai, the sound of that Shehnai is what high pitch sound. Okay, someone shouting in your is one type of what? Shrill sound. Rough sound, hoarse type of sound, just like the sound produced by me, is not high pitched, it is rough, it is hoarse. It is also called as hoarse sound. Rough sound. So I think you are getting the pitch. Pitch means what? Shrillness. Shehnais and many such instrument girls can shout loudly and they can produce a high pitch sound. Okay. Now pitch depends on one of the characteristics of wave, and that is frequency. Pitch is directly proportional to frequency. As the frequency of sound wave is higher, the pitch is higher. Frequency means number of waves produced in 1 second. Now, consider this is one of the graph. Okay, and another graph of same time. Let us say this is time. So same time, times are same for both the graph. Height of wave is also same. I have tried. So what is same? Amplitude is same for both. Height means that this maximum displacement of wave from mean position is same for both. So amplitude is same for both. But how many waves are produced here? Let us say this is 1 and 2 waves are produced in certain time. And here what? 1, 2, 3, 4, 5 and 6 waves produced in certain time. So I think here the frequency is higher. Let us say this time is 1 second. So this time is also 1 second. So 2 waves in 1 second means the frequency is 2 hertz. And 6 waves in 1 second means frequency is 6 hertz. So which is the high pitch sound? Or you can say which sound should be the sound of a girl? I think this one. And this will be the sound of one of the, because this is having the high pitch sound. So more is the frequency, more is the pitch. Okay. Second important term is loudness. Loudness. Pitch is shrillness. Loudness means how more force you are applying when you are speaking. If I have to call my friend which is away, or we can say certain distance away from me, or over that side of road, so I have to shout. I should not scream. I have to shout and call it. So loudness means what? How forcibly you are speaking. What force you are applying to the molecules of air. By what force you are pushing the molecules, so what the molecules go larger distance from mean position and they do the large vibrations, large amplitudes. So the sound can travel a long distance. Try by yourself. You cannot call your friend which is at certain distance away from you by screaming. You have to speak loudly. So normally boys and the men are having the very loud sound. Girls and the ladies normally having the high pitch sound. They can scream very well, and normally boys and the men can speak loudly very well, because they can apply more force to the molecules present around in the air. So loudness depends on which quality? So loudness is directly proportional to amplitude. Directly proportional to means what? As the amplitude increases, loudness increases. Amplitude decreases, loudness decreases. So when these two quantities are in the same proportion, same relation, they can be represented by this symbol called directly proportional. Mathematically, if I say x proportional to y means what? As the value of y increases, value of x also increases. As the value of y decreases, x also decreases. So whatever the effect is there in one of the quantity, same effect can be seen on the other quantity. This type of proportion is called as direct proportion. Okay, so second was what? Loudness. Loudness depends on amplitude. Third is a quality. Quality of sound is also called as timbre. Timbre of sound. For example, you and your five friends, means total 6 persons are there. Okay, close your eyes and ask each and every friend, speak one by one. Say they are saying your name. Okay, so in spite of your eyes are closed, if someone is speaking your name, you can find out that which one of your friend is speaking. In short, we can identify a person because of what? Because of its sound only. So there is something different in each and everyone's voice. If you and your 5-10 friends are there, You can identify each and every one just by their sound, just by their voice. Each and every person, each and every musical device, each and every sound producing device having its own quality, having its own timbre, which makes it different from the others. So what do you mean by quality or timbre? Is one type of waveform. That means, you see, actually it is not in your syllabus, just the name is there, but I want to clarify something. For example, here is one of the wave. Let us say this time is 1 second. How many waves are completed? 1, 2, and 3. So what is the frequency? Frequency is 3 hertz. Okay. And let us say this is height. Let us say it's 2 centimeter. So what is the amplitude? Amplitude is 2 centimeter. Let us say this time is again 1 second. Okay. How many waves are there? 1, 2, 3. Okay. So what is the frequency? Frequency is 3 hertz. Let us say this height is 5 centimeters. So what is different? Amplitude is different. The amplitude is 5 centimeters. So larger the amplitude, larger is the loudness. So out of these two, which is loud sound? This one. And with what do you think about the pitch of sound? Pitch depends on frequency. Because the frequencies are same, both sound are having the same pitch. Pitch is same, shrillness is the same, but loudness is different because of amplitude. Now what happened when both the things are same? Amplitude is same as well as what? The frequency is also same. Then what do you say? Both the sounds are same? Both the sounds are heard same to me or to you? No. Then also you can hear them differently because of this quality. Look at this. Consider this is okay. So height is same, so amplitude is same as 2 centimeter, frequency is 1, 2 and 3 same. But look at the waveform is different. What is different? Wave formation is different. You can see that the wave formation is different here, and so this is nothing but the quality, the waveform, which makes each and every person different from each other. So what gives you the quality? Quality is one type of waveform which makes each sound unique. So if someone asks you which is the characteristics of sound through which you can identify your friend's voice without watching him or her, that is the quality of sound. That is not, see, if 5 or 6 girls are screaming, you cannot identify that which one of your friend is screaming. No. So with the help of pitch you cannot identify the person. With the help of loudness you cannot identify the person. With the help of quality, timbre, or you can say waveform, through which you can identify the person. So quality or the timbre which makes the sound unique, or you can say quality or timbre which makes the sound of each and every person different from the others. One more thing to learn, and that is tone. What do you mean by tone? Tone, single tone is there. So I think that is, tone means nothing but the sound of single frequency. Sound of single frequency is called as tone. Let us say one of the musical instrument is playing, and that is like this, having a uniform wave formation. Here the frequency remains same everywhere. If it is like this, let us say this is the this way. So you can see that here the frequency is very high, here it decreases, again it is high, again it decreases. So it is the mixture of many frequencies. This is a single frequency sound. It's like the sa in the musical tone, re. So these are the single tones. Sa is one of the tone having the same frequency. Re, this way. So tone means the sound of single frequency. Some mixture of sound. Now it's very important. Consider look at this. It's a 1, 2, 3 and 4 waves. Like this. 4 waves. And now from here the frequency decreases. 1, 2, 3 for a long time. And then again it frequency increases. More waves in short time. So it's 1, 2, 3 and 4 like this. So this structure repeated here. And let us say now this structure repeated here. Okay, so 4 waves like this, 3 waves like this, 4 waves like this, 3 waves like that. So this is the mixture. This is not the tone. It is not a tone. It is a mixture of certain frequencies. But if you see, it is a mixture of certain regular frequencies. So that is called as note or musical note. What do you mean by note or the musical note? That it is a mixture of regular frequencies. Mixture of regular frequencies which is pleasant to listen. See, that type of mixture which I have just drawn is pleasant to listen. It's a mixture of many frequencies but still pleasant. It's one type of musical note. Okay, but if I draw this type of structure, so what is this? Some frequencies here, then frequency decreases, then again increases for a short time, and then now the waveform changes. It's a mixture of irregular frequencies which will not be pleasant to hear, and such type of waveforms is called as noise. Noise. So what do you mean by noise? Noise means it's a mixture of irregular frequencies which is unpleasant to listen, are always called as noise. It's a mixture of very irregular type of frequencies which is very unpleasant to hear. So these are some important terms connected to sound. Still to clarify, still one more is very important. Let me clear it here only. One is there is intensity of sound. One of them is intensity of sound. Intensity of sound, see, it is not in the detail in your syllabus, but still let me clear it. Intensity symbolized by I. Intensity of sound means I means the sound energy passing through unit area in unit time. Means let us say one of the sound, let us say this is one of the pipeline and one of the sound is played here. Means let us say one of the music is playing here. So this is the area in which the sound goes. Now the same sound producer is here. Same sound producer. But this is the pipeline now. So sound is passing from larger area or not? Yes. So as the area increases, intensity decreases. Here is what? The sound has to pass from a very small area, so intensity is very high on the other hand. But here the sound has to pass from the very large area, so the energy distributes and the intensity decreases. So I have the simple formula, intensity is equals to energy per area in unit time. From this formula, you can find the unit of intensity. Unit. See, energy is always measured in terms of joule, area in terms of meter square, and time in terms of second. As we know, joule per second is represented by watt. So it is watt, and in the denominator we have meter square. So watt per meter square is the intensity of sound. One of the question is there in your textbook that differentiate between loudness and intensity. So there is only thing different between these two. Loudness depends on amplitude. Loudness just depends on amplitude of wave, and intensity depends on energy passing through unit area in unit time. See, the unit of loudness. Unit of loudness is decibel. Decibel. Actually, the unit is bell. I think you have heard the name of Alexander Graham Bell. So, in the memory of that scientist, the unit of loudness is bell, but not the whole name is written. It's simply B, bell. And tenth part of one bell is called as 1 decibel. Deci means 10 raised to minus 1 means 10th part of anything. So here the 10th part of one bell means 1 decibel. So normally the sound loudness is measured in terms of decibel. Just for your kind information, let me give you some information that our normal conversation, not the shouting. If we, our family members or friends are sitting at our home and just we are discussing something, so that is a normal conversation. Normal conversation always happens on 60 decibel near about 60 decibel sound. That is a normal conversation. 80 decibel, 100 decibel, somewhat loud sound. More than 140 decibel is called as noise. Extra shouting, speaking loudly. 4 or 5 different persons are speaking loudly at a time. That creates what? That creates noise to us. So normal conversations are there on the 60 decibel. Now the loudness depends on loudness having no definition. It depends on amplitude but having no definition. Because loudness is different. It depends on the ear of a person. So it depends on the capacity of ear, of hearing. For example, you and your family members are sitting in the living room and all are watching TV. So the sound or the voice or volume of that program going on, somebody saying that please increase the volume and someone saying please decrease the volume, because the sound which is there or the volume of the program is loud for one person and not loud for the other person. Loudness differs. Loudness differs person to person. Such type of characteristics which depends on person to person is called as subjective property. So loudness is a subjective property. Subjective property means it depends on person to person. Some particular music is going on and that may be loud for me, but they may not be loud for the other person. They are dancing, but I got irritating because of that. Maybe depends. For example, the pop songs, the remix songs are creating a lot of loudness and a lot of. So I don't like that. So I particularly, personally, I am not liking it. Means that is more loud for me. The old songs which are very soft, having soft music and soft musical tones. So I think I like it. So that sound will never be loud for me, but that may be loud for your generation maybe. So it depends on person to person. That if you are liking the sound, that will not be loud. For example, in Navratri we see the disco dances are going on and see the loudness of the music. So that may be what good for you. You are dancing and you are playing garba here and there, but that may be not good for the patient nearby hospital, because he or she is not liking it. He is getting the irritation. That is the noise for him or her. So this way, so loudness differs person to person, and such type of characteristics is called as what? Subjective property. So loudness is a subjective property. It depends person to person. Intensity is not subjective. Having a particular definition, having a particular unit, and it is same everywhere. Okay, so intensity is objective property. Objective property means it is not depend on person to person. Depends on definition. Loudness having no definition. Yes, loudness depends on amplitude. Intensity depends energy passing through unit area. In unit time, one type of definition for this intensity. Okay, still we have to discuss one more topic, and that will be in the next lecture. We are going to discuss again the speed of sound. Speed of sound depends on which factors and how it goes from one point to another. Till then, please learn all these topics. 7 different important terms we have solved in this. Page number 165, page number 166 of your NCERT textbook, having a lot of blue colored questions. Blue questions are there. Solve these all blue questions. You can easily solve because all the answers of these questions are covered in this video. Best of luck.